This week on the Creation Today show.
In the early 2000s, late 90s, there were all of those discoveries from China with all these animals with feathers and soft tissue. The preservation of the minerals over there, something about the way the fossils were formed, led to a lot of soft tissue preservation. And so we see a lot of these feathers preserved and other soft tissues preserved. Evolutionists, they're trying to tell a story, right? They're trying to tell a story without God. They interpret the evidence from that worldview.
Welcome to the Creation Today show, where we bring together interviews with experts and solid Bible teaching. Your host, Eric Hovind, affirms the ultimate authority of God's Word, the truth of creation, and why it matters to you.
Should KFC really be KFD? We don't need Kentucky Fried Chicken. What we're really eating is Kentucky Fried Dinosaurs. Did dinosaurs evolve into birds, and could dinosaurs fly? Listen, it's a claim made by every evolutionary scientist today, but kind of like the theory of evolution, we might be experiencing what's known as confirmation bias instead of real science. I want to unpackage this today. If you're new to the Creation Today show, my name is Eric Hovind, and we're just on a mission to disciple the whole world one person at a time. We want to turn stumbling blocks that keep people from seeing Jesus as the creator and redeemer of mankind and turn those into stepping stones on your journey or somebody's journey to know the truth about God and his creation. Today we're tackling, did dinosaurs fly? Did dinosaurs evolve into birds? And if you watch any evolutionary or know anything about evolution and the worldview, or watch the PBS or Discovery Channel, or read the books, or watch Dinosaur Train, everything in between, they're pitching this idea like it's a gospel fact. Dinosaurs evolved into birds. And that's what I want to answer today. Did they evolve into birds? We got to look at the science. And of course, as we always do, we're going to dig into scripture to see if this is true. My guest today works for Answers in Genesis, genius of a guy. He's a graphic designer, web developer. He's got a brain designed by God that loves dinosaurs. Just wait until you hear him say all the names, those ones that are really hard to say. They roll off his tongue like it's natural. It's really incredible. Ladies and gentlemen, please help me welcome Joel Leineweber. Joel, thank you so much for joining me today.
Yeah, thanks for having me, Eric. So happy to be here.
What has made you so fascinated with this whole dinosaur bird thing, and dinosaurs specifically from a young age? Why did this captivate your mind?
Yeah, well, a lot of little boys grow up loving dinosaurs, right? But for me, I never grew out of it, and I've always had an interest in birds too, and bird watching. So this research was just right at my alley. It was such a fun project to be able to work on.
Well, very cool. I'm not doing bird watching right now. I'm doing squirrel watching. With everything that happened with was it Peanut the squirrel that they killed recently? A squirrel this morning fell out of a tree. My dog found it, and I right now so far for 3 hours have been taking care of it. So I feel like I'm more of a squirrel guy right now. So did dinosaurs evolve into birds? Did dinosaurs fly? We got a lot of questions to ask. I thought the best way to start this would be to go through a little bit of a review on the history of this whole dinosaur to bird evolution. I'll tell you what I know, and then I'm going to let the expert, you, fill in the gaps of what I'm missing, okay? I know that in 1861, so like 100 and almost 150 years ago, they discovered Archaeopteryx. And it was thought, hey, maybe this is some kind of, reptilian transition type thing. And it started asking the question, where did birds evolve from? Then Thomas Huxley, known as Charles Darwin's bulldog. Remember, Charles Darwin wrote his book, 1859. So 1859, Darwin's book, 1861. Now evolution is, out there. 1861, Archaeopteryx. It's like, well, maybe it's true. 1870s, Huxley kind of says, hey, this is it. This is definitely an animal that evolved from a theropod type dinosaur. Then in the late 1800s, they kind of distanced themselves from that and thought that birds evolved from a reptile, but more like a crocodile type ancestor. Then in the 1920s, that book came out, The Origin of Birds by Hellman, maybe it's German, I think. And he's basically reinventing the idea, or resupposing the idea that birds evolved from a reptile ancestor, but maybe not dinosaurs specifically. And he said they don't have these certain ones don't have a wishbone. And then it really wasn't until the 1960s that a scientist named Ostrom discovered, man, you're going to be able to say these names. I can't even say them. Dyna,
Deinonychus.
that's the one, Dionicus,
Yep.
in
Yep.
1964.
Mhm.
And from there, then you had the 70s and 80s where they're finding more things. Then really the 1990s is when we started discovering what is modernly called like a dinosaur bird type creature, supposing that there are feathers on dinosaurs or maybe an unknown type of dinosaur. And then 2000s, of course, more feathered dinosaurs. 2010 CT scanning comes about, and we start thinking, okay, maybe, or evolutionary scientists start going, it looks like dinosaurs evolved into birds, and they start presenting it as gospel fact. So
Yep.
that's kind of the timeline that I know of. That I'm
Mhm.
sure I missed a lot there, but is that kind of the basic overview?
Yeah, for sure. I'm glad you brought up Ostrom and Deinonychus. That was a key one where he started to say, hey, this has some bird-like characteristics to it. I'll talk more about him a little bit later. And then also in the early 2000s, late 90s, there were all of those discoveries from China with all of these animals with feathers and soft tissue. And it was like, whoa, we don't get a lot of fossils like that in the US. But the preservation of the minerals over there, something about the way the fossils were formed, led to a lot of soft tissue preservation. And so we see a lot of these feathers preserved and other soft tissues preserved on some of these animals. And so, yeah, I want to talk a little bit about too during this whole time and this whole history, evolutionists, they're trying to tell a story, right? They're trying to tell a story without God. Um, and so they interpret the evidence from that worldview. And so they start to change definitions of words along the way. So the definition of feather, I'll talk more about that later. That has changed over time based on their worldview. The definition of dinosaur, it's changed to include birds now. And so that's a big change.
Now I know this was brought up to me just last year, a little over a year ago. I did not realize that inside the creation community, people who say, no, I believe God created the heavens and the earth, I'm looking at all the evidence as though God did it. I didn't realize there was kind of a two different camps of ideas on dinosaur or dinosaurs with feathers versus dinosaurs. Like, I'm hoping we can get some clarity on that. What's going on with that, and how did that come about? The whole controversy of did dinosaurs have feathers or not? And I guess there's some saying yes, some saying no. Maybe it depends on definition of what you're talking about, but catch us up to speed on that for the people out there that love creation science.
Yeah, so obviously we're not going to limit God, right? God could have created dinosaurs with feathers, right? God could have done that. But the joy of science is figuring out what God did do, not just what he could have done. He could do anything, but what did he do? And so, but yeah, there's been a lot of history there with creationists studying this material and diving into it and trying to figure out, okay, is this idea of dinosaurs with feathers, is that coming from just the evolutionary worldview, or is there actually good evidence for this? And so that's what we'll look at some of today is the difference between those. And depending, some creationists, Christians, I believe, are landing in one camp where they say, no, we think the evolutionists, they're not being biased about this. We think there's evidence for it. And then today I'm going to present a view that explains, well, there's some evidence that doesn't seem to line up with that. But it does change some things about certain animals that we've thought have been dinosaurs for a long time. And so we'll get into that a little bit too.
Very interesting. Okay, big picture though, those in the creation camp that are trying to figure this out or having discussions about this, nobody is saying in the creation camp dinosaurs evolved into birds, and that separates us from the evolution camp, which says dinosaurs evolved into birds. Is that kind of a good way to divide that?
Yeah, definitely.
Okay.
There's not enough. Uh, One of the ways we know that God didn't use evolution is because evolution couldn't happen in 6 days. I mean, evolution couldn't happen anyway, but definitely not in the 6 days of creation week. And there's just not enough. Evolution doesn't create new information, right? So I'm not aware of any creationists that believe that feathers came about from a non-feathered creature or anything like that. Yeah, we're definitely on the same page
Good.
there.
Good. We're on the same page. Okay, to my social media viewers out there, to the television audience, and my podcast listeners, you're going to love this. So go ahead and like and share and subscribe. And I'd love you to come over and be one of our partners at creationtoday.org. It's literally a name your own price. You just support us for whatever you want per month to help us spread the gospel around the world. And you get access to everything we do on the Creation Today Plus side of our platform. Joel, I'm ready to jump into this. You've got a presentation that's going to help us visualize what you're talking about. Go ahead and launch what we need to know about the whole dinosaur to bird evolution. Did it happen? Did it not? Did dinosaurs fly?
Awesome. Let's go. Feathered dinosaurs, like Eric said, we see them everywhere, right? Like this is a feathered Therizinosaurus from one of the recent Jurassic World movies. It's got just covered in these feathers. This is a supposed feathered dinosaur called Pyroraptor from one of the same movies. If you do a Google image search for feathered dinosaur, it'll give you thousands and thousands of results. You can even ask AI to create a feathered dinosaur for you, and it will happily comply.
Wow. That's beautiful too, man. It looks so, and honestly, those pictures sell it. If I was a kid, I'm like, I'm a believer. All you have to do is show me a picture.
Right? Exactly. Yeah, it's very convincing. And even toys, right? So someone I know found this in a church nursery. It's a feathered oviraptorosaur of some kind, and even so, it even makes its way into the church, into our homes, without us even realizing it, because it's everywhere, right? And it's been cool being part of this research because we're covering over 100 years of research, like Eric was talking about, over 100 species that are called feathered dinosaurs, hundreds and hundreds of books and papers. So we're really just at the beginning of this, of really figuring out what's going on here. But we've made some really great observations. But first, I want to take a step back, and Eric, you've been looking at this stuff for a while. I think you can help me a little bit.
Okay.
Identify whether this animal is a dinosaur or a bird. What do you think this looks like, a dinosaur or a bird?
Well, I'm going to go with the hand position, the head position, the feet position, and the tail at that length. I'm going to just go out on a limb here and say dinosaur. I'm going with dinosaur on that one.
Yeah, it looks like a dinosaur, right?
Yeah.
All right, how about this one?
Well, that one with the tail structure, the center of balance right there over the feet, beak the way it is. I'm going with bird on that one.
It looks more like a bird, yeah. But the problem is that's based on the same skeleton. So these are two drawings based on the exact same skeleton. And you can see that skeleton here. And depending on how you pose it, it can look like a dinosaur or it can look more like a bird. And so
now, hang on. So is it going to be one or the other, or is it just your...
It is.
Like
yeah.
that skeleton is one or the other. You're going to tell us which one it is.
I'm going to tell you which one it is. Yeah, this animal is Microraptor, and we're going to spend some time talking about him a little bit. But it's one of these ones that has been potentially confusing for some researchers, because there are things about it that historically some have said, well, that looks more dinosaur-like, and other researchers will say, well, no, that looks more bird-like. And so it's not, there are some differences between these animals and some birds today, but does that mean they're not birds? We're going to talk about that. All right. So how do we know? And if you look at this, you might say, all right, well, there's some things about this. This is Archaeopteryx that Eric was talking about earlier. And you might say, well, I see some things in Archaeopteryx that don't look like a bird, right? Like it's got wing claws. I mean, look at these big old claws on the wings. Can't you use that to say that this was a dinosaur, not a bird? Well, if you go to a grocery store and pick up a chicken wing, and look at the little...
No, there's not. Are there really?
There's claws, yeah. Most of them have a little claw on the wing. Yep.
Hang on. So every time I go to Buffalo Wild Wings and get my wings, am I eating that thing, or are we cutting that thing off?
It usually comes off before you eat it. Yep.
Okay.
But yeah, it's on the end of the wing. But if you get a full chicken wing, if you buy a full chicken, you can usually find one on there.
Oh my word.
Here's an ostrich wing. Look at the size of the claws on that ostrich wing. Turns out there's a ton of birds today that have claws on their wings. Around 40% of the different orders of birds have members with wing claws. You just can't see them because they're covered with feathers. right? So we can't use claws to tell whether something's a dinosaur or a bird. Well, you might say, what about fingers? Like clearly there's like 3 digits going on there. Couldn't that be like the hand of a dinosaur? Well, again, it's kind of hidden by the soft
No,
tissue, but there's 3 digits inside of a bird wing. And
really?
and a lot of scientists, a lot of researchers miss this in the fossil record or don't think about this too much because there's in modern adult birds, there's bone fusion that happens as they turn into adults. So you can see that blue bone on the right there. This is a chicken. Again, a chicken wing. Those 4 bones kind of fuse together into something called the carpometacarpus. But in juveniles, these bones are separate. They're 3 separate digits. And so you can see in a lot of these extinct animals, there's the same structure is all through there. So what about teeth? You might say, well, birds don't have teeth today, right? Archaeopteryx has teeth. And you're right, birds don't have teeth today. This is a goose. You can see it's got some structures that look like teeth, but it's really a serrated beak. But in the fossil record, we do find animals that are clearly birds and clearly have teeth. So here's 6 examples of that. Even evolutionists would agree that, yes, these animals are all birds in the fossil record, but they have teeth. So we can't even use teeth to tell if it's a dinosaur or a bird. So a lot of these things are misconceptions that, oh, this is how you can tell them apart. Well, it's not really.
Now, is this something that evolutionists use? All of these things, the claws, the teeth, do they use all of those as evidence? Because if I was an evolutionist, I'd be like, well, that's evidence that they evolved into birds. Is that all pieces of what they use?
Yeah, so they use these characteristics as part of their storytelling. When they observe this evidence, they say, well, yeah, that's evidence that teeth evolved into a beak, and this is evidence that the claws slowly got smaller, and then as the animal learned to fly and things like that. So they've got a whole story explaining this. Yeah.
Okay. All right.
Um, some of you might have noticed Archaeopteryx does have a bony tail, and birds today they have a shorter tail, and we'll talk more about that. But turns out that the concept of this tail is very important to a bird, and we'll talk more about that later. So as we mentioned before, could God have created dinosaurs with feathers? Yeah, of course. But let's talk about creation week. What day did God create dinosaurs on? He created them on day 6, right? God made the beasts of the earth according to their kind, the livestock according to their kind, and every creeping thing that creeps on the earth according to its kind. So that was day 6. Well, what day of creation week did God create birds on? That was day 5. Every winged bird. It turns out this winged concept is really important. So God created birds and dinosaurs on different days. So that's kind of a good indicator that, well, maybe these animals are really different. So we kind of started with the hypothesis. The hypothesis was God only created feathers on birds. That's it lines up with what we see in Genesis, from what we can tell, and it lines up with what we see in the world today, right? We don't see reptiles with feathers. We see birds with feathers, and we only see birds with feathers. So that was kind of our hypothesis, and we said, all right, we're just going to start with that as our hypothesis, and then evaluate the data against that and see what we come up with.
I do have a question on that to say, okay, birds day 5, dinos day 6, dinosaurs aren't, I mean, are we down to because I've always wondered this. I was just on college campuses and they're always asking, well, what is a kind? And I'm like, well, what is a species? And are we putting our modern classification system kind of on top of the biblical text going, okay, how do we fit these in there? Or how do we evaluate that when it comes to, because I know I'm always frustrated. Linnaeus's classification system is not the same as the Bible's. And I'm always like, okay, how do I talk to a secular person who is following the kingdom, phylum, class, order, family, genus, species, and I'm using the biblical kind, which is more, you got land animals, you got flying creatures, I'm always wondering, like, I'm trying to talk in 2 different languages here at the same time, it seems like.
Yeah.
How do you guys handle that?
Yeah, it gets a little bit challenging. You're right, because
Okay.
like you said, the Linnaean classification is not inspired by God, right? And so
Right.
And so that's part of the challenge. Like generally we say, all right, the idea of a created kind usually corresponds to around the family level, right? Genuses and species often We see it can often crossbreed, interbreed, which indicates they would be from the same created kind. But there were more than just birds created on day 5. There were other flying creatures. Flapping creatures is kind of the literal word for that, flying or flapping creatures.
So
And
like
so,
a bat would have been
right,
day 5, not day 6. A bat, even though we don't classify it as quote a bird in our modern classification system, biblically it would still be the flying
right.
kind.
Yeah,
Okay.
exactly. And, pterosaurs, they're flying reptiles. They're not technically dinosaurs. A lot of people think they are. But pterosaurs would have been created on day 5 because they're flying, flapping creatures.
You're ruining a whole bunch of kids right now thinking that they've got a dinosaur with their. And so, what about the pterosaur?
Yeah, so a pterosaur is not a dinosaur. They're just pterosaurs. And
They're just listen, just pterosaurs. You're killing me, man. They're on dinosaur train. Why
I
would they
know,
be on
right?
dinosaur?
Yep.
Okay,
Yeah,
all
extinct reptiles. Yep.
right. Okay, I just wanted that understanding because okay, you're saying hypothesis God only created feathers on birds because birds or flying creatures were made on day 5.
Yeah, so the idea is, there are reptiles that can fly, but they don't have feathers from what we can tell. And so,
Okay.
yeah, trying to discern those differences. But you're right, it is a little bit challenging.
Okay. All right.
So let's look at feathers for a second, because there are various types of feathers, right? We've got these flight feathers, we've got tail feathers, you've got semi-plumes and phyloplumes and all these technical words. But at the end of the day, a feather is a branching structure. It's got a quill down the middle, and it's got these bristles that come off the side. And so we would expect that animals that are birds would have these branching structures, and animals that are not birds would not have these branching structures. Now we do find some of these fossil animals with some soft tissue preserved, like this guy. This is Sinosauropteryx, and you can see he's got that long tail there, and he's got these dark little fiber things coming off of his neck and back, and we call those filaments, but they're not branching structures. So this is again where evolutionists have come along and said, well, these were in their story, these were structures that evolved into feathers, so we're going to call them feathers. So they use the same word, even though they're not branching structures like feathers.
So, and that's where language, just like the word evolution itself. Okay, well, hang on. What do you mean by evolution? When they say feathers, it's like, okay, well, hang on. What do you mean by feathers? Because that doesn't fit our really a feather definition.
Right, exactly.
Okay.
Yeah, so the way we've been differentiating these two is we say filaments, they're not branching structures. We don't know exactly what they are. That's an ongoing topic of research. The best guess so far is some collagen fiber that was actually in the skin. And so there's been some studies that have shown good results with that. But a feather is a branching structure. So if we see a clear branching structure on a fossil, we say, okay, yeah, that's a feather. And we do find those in the fossil record too. So this fossil on the right is Archaeopteryx. We were talking about him earlier. And then this fossil on the left is Microraptor. So that was the animated skeleton we saw earlier. So we do find feathers on Microraptor, true branching structure.
Okay. Now
And then,
that makes me go, okay, so dinosaurs could fly, or again, it comes down to what's the definition. Okay, I'm sure you're going to get into this. All right.
right, yeah. So, and Microraptor is one of the ones that one of these other young Earth creationists who believes dinosaurs had feathers. Microraptor is one of the ones that convinced him that dinosaurs must have had feathers because it's a dromaeosaur, whereas a lot of scientists say Archaeopteryx was probably a bird. They debate it back and forth. It's like right on the line for evolutionists. But dromaeosaurs, a lot of evolutionary scientists believe that they were dinosaurs. So that was one of the discoveries that really made people scratch their heads and say, "Oh, okay, we got something we have to figure out here."
So Microraptor is the dromi. How do you say it again?
Dromaeosaur, yes.
Dromaeosaur. Microraptor is a dromaeosaur, and a dromaeosaur is classified as a dinosaur. And so that's why, because that has feathers, he'd say a dinosaur has feathers. Okay.
Yep. So this is a diagram, supposed feather evolution from National Geographic, adapted from National Geographic. And you can see they've got these different stages in their story, right? So stages 4 and 5, they look like normal feathers. They've got two different types of flight feathers here. And you can see we find those in those animals underneath there in that group. And then stages 1 and 2, they're these filament structures we were talking about. They're not branching structures, and you can see we find those on some of these dinosaurs. Stage 3 is hypothetical. We haven't found it yet. So it's part of their story, but they don't have a good explanation for how stage 1 feathers, these simple filamentary structures, evolved into these incredibly complex branching structures.
Okay. Now, do we know anything from genetics on that? Like genetically, do they come from the same spot in the gene where it could turn into that? Or I know with epigenetics, is it like, oh, it's just a matter of turn this certain switch on and then it produces that? Or have we learned anything from the genetics?
Well, and that's part of the challenge is because we have modern examples, living examples of feathers, branching structures, feathers on birds, right? So we can study the genetics on that. But these filaments, we don't know enough about what they are. Like we don't have living animals that we could say that's a filament and that's what that animal has. So there's no way to even study it at that level. It's just these little filaments, these little fibers in the soft tissue in these rocks, and that's all we have. They are doing a little bit of
Okay.
they're doing a little bit of molecular study on some of these, um, but and they're looking at different types of keratin and things like that. But none of it's very conclusive, and keratin can change at different temperatures, and there's a lot of challenges there.
Okay.
So if we look at this group of animals called theropods, and then we look at a group within there called Maniraptora. So these are animals that they have a particular type of hand. The manus is the scientific term for a hand, so Maniraptora. All of the true feathers, these branching structure feathers, are found inside of this group called Maniraptora. Now we do find filaments outside of this group on these other animals, but only the branching structures are only found inside of Maniraptora. So that was our first clue. It's like, oh, well, let's study those animals specifically and see, do they look like dinosaurs or do they look like birds? And so that's what I want to dive into next is 7 dramatic differences between dinosaurs and birds that we found through this process.
This is getting down to where is this divide coming from? Why are we coming to this conclusion and they're coming to this conclusion? So this
Exactly.
is really going to help us, isn't it?
Yeah, this is going to be great.
Okay. Okay.
And a lot of the diagrams and artwork and research is also presented in this paper on Answers Research Journal. So if you're really into the technical details and you want to go look into that, feel free. And a lot of my research is also based on what Dr. Haynes has done. And she's got an amazing paper as well on Archaeopteryx specifically and really goes into the details on that. So let's jump in. All right. So as we've researched this and dug in and really looked into all the technical details, we found something very profound. And that is birds have wings.
Well done, Cole. Well done. Ah.
I know. You know, sometimes it takes a lot of work to state the obvious.
After all this research and all this time and energy,
yes,
you should get another government grant to decide if birds have beaks or legs.
Yes,
okay,
exactly. All right. So these first 4 characteristics I want to talk about are related to the wings. And so let's dive in. So they don't just have wings, they have wing feathers, right? Birds have these beautiful wing feather structures, not filaments. Again, we're talking about branching structures here. And we see these wings, when we see these feathers in these fossil animals, like Archaeopteryx here, they're arranged like a wing. Here's the same for Microraptor. You can see it's arranged like a wing. This is another one called Caudipteryx, and if it's an oviraptorosaur. And you can see it's a small wing, but it's a wing nonetheless. And so if we look at the arrangement of feathers, this is a dove, living bird. You can see they're arranged into these different groups. You've got the red feathers that are the primary feathers attached to the hand bones. You've got the secondary feathers attached to the arm bones, and those little gray feathers that are attached to that first digit called the alula. This is very consistent across birds that their feathers are arranged in this way. That's the way God designed them. And lots of design, just incredible design, has gone into the structure of a wing. And so these aren't just feathers randomly attached to these animals. These are feathers that make a wing. And so
yeah, it's like you'd have to say, look how lucky that dinosaur was to grow those in the perfect spot. And then all
Exactly.
these other changes take place so
Yep,
it can fly and the
exactly.
brain can learn 3D. Like, oh my goodness, this
Yeah,
is
there's
incredible
so
design.
many things. So this is Microraptor. You can see the feathers are arranged just like a normal bird. And Caudipteryx, same thing. His wing is smaller. He may have been flightless, but the feathers are still arranged the same way, just like flightless birds are today. So these aren't
So
integumentary
even flightless birds have the same structure.
for the most part. There are some flightless birds, but if you look at ostriches, they have the same arrangement. You know, rheas.
Okay.
There's some that have like kiwis and cassowaries. They have similar bone structure to some degree, but they don't have as they've lost a lot of the wing feathers.
All I think of is Ray Comfort when you say kiwis. So sorry.
Yeah, there you go.
All right.
So another part of the wing is the soft tissue around these feathers, right? So we've got these things called patagia, propatagia, postpatagia in the red and blue there, and they're complex system of tendons, ligaments, and nerves that automatically fold the wing and fold the feathers with the wing and automatically open the feathers when the wing opens. So that none of this is an accident. None of this they're not just randomly attached here. God designed the skeletal system and the system of tendons and nerves and the feathers to all work together as a wing structure so that the bird can fold its wing and put it away and keep those wing feathers safe. So it's just remarkable how God designed this system. And it's actually a passive system. So all the bird has to do is flex its elbow and the whole wing opens up.
Oh,
And then it bends
wow.
its elbow and the whole wing closes. So it's really a cool system. Talk about
Yeah.
irreducible capacity.
Transformers got their ideas from this right here. This is cool.
Right.
I mean, seriously, it's like it all just works together. Just happens to work together as an incredible design.
Right, exactly. So if these feathered maniraptors are birds, then we'd expect to find evidence of some of these tissues, right? So this is a feathered maniraptor called Anchiornis, and you can see it's got evidence of that same soft tissue right there. We don't find a lot of soft tissue in the fossil record, but in this animal we did, and it really is just amazing. Another thing they found on the same fossil, if you put it under a particular light, is you've got feather follicles on the skin. And so if you look at that image on the right there, birds, and evolutionists don't talk about this a lot, but birds need a whole system to maintain their feathers. And so every one of these feathers that's in the bird's skin has a complex web of nerves, blood vessels, and muscles that attach to those feathers. It's just a system built into the skin. It's got this mesh built into its skin, and we find evidence of that in the fossil record for these animals. So they can move those feathers. They can feel if those feathers are moving. They've got blood vessels going to those feathers so that they can grow new ones and shed them and replace them. Uh, it's a whole system that would have needed to evolve before the first feather was even in place.
Wow. And we see that whole system right there on Microraptor.
So this is Anchiornis. We do
Oh, and
find,
Curious.
yep, we do find evidence of the patagia in Microraptor, but then in Anchiornis,
Okay.
we also found these feather follicles arranged very similar to modern birds. So that's our first criteria. Our
Okay.
first characteristic here is not just wings, but wing feathers. And these feathers are arranged just like a modern day wing. Second one is swivel wrist. So if you hold your hand up, Eric, and then you try to bend your wrist sideways, I can get mine to about 45 degrees, but that's about it. I
Yeah.
can't go much further than that. And that's because
Yeah. It's,
I have a human wrist, right? It's designed to bend this way more than it bends this way. So birds have a very different very different wrist structure as part of their wing. Their wrist can swivel, and so when they fold that wing, their wrist swivels, and their fingers can almost touch their arm in some cases.
wow.
So it
Yeah.
goes all the way up. Well, uh, if these feathered maniraptors are birds, we'd expect to find evidence in the fossils of this bone structure. So birds have a special bone. If you look at that chicken in the middle there, it's called the semilunate carpal. It's a little half moon shaped bone in the wrist that allows that wrist to swivel. And so if you look at Microraptor on the left and Sapiornis, an extinct bird, you can see they both have that same little blue bone that allows the wrist to swivel. But if you look
And we
at,
can literally see that from the fossils. We can literally see that.
yes,
Wow.
many of these maniraptors have that bone, that special bone.
I wish the all my Creation Today partners and then the ladies in the office, I wish I could have their video on to watch them doing this right now. They get to watch me doing this. I'm like, girls, there's shows over there just watching you guys all try this. All right, all
That's
right.
right. Dinosaur wrists can't do this. Like the Allosaurus here, it can't swivel its wrist. Its wrist bends more like a person, and they have that grasping ability, but they can't swivel their wrist. So it's a big difference. And if we look at, it's very consistent across the non-feathered dinosaurs, these, Allosaurus, Sinosauropteryx, these Compsognathus, many of these other ones, and these feathered maniraptors across the top there, all have this special swivel bone. And this is a big problem for evolution because here's a quote from an evolutionist. Somewhere along the way from early dinosaurs to birds, wrists changed so much that we could be excused for thinking birds don't even have them. Wrists went from straight to bent and hyperflexible, allowing birds to fold their wings neatly against their bodies when not flying. Underlying this change is a drop in the number of wrist bones from 9 to just 4. So
Whoa.
the wrist was completely re-engineered. God designed these creatures very differently, and even the evolutionists recognize this, and they're like, how did this happen? What would have caused this to happen? So this creates a big problem for evolutionists because somehow these animals, these dinosaurs, had to evolve this swivel wrist and these wing feathers that are coming off the fingers. So this animal, it's supposed to be like hunting with these forelimbs, with these claws. Now its wrist bends sideways, so it can't even like pull things toward itself, and it's got these big feathers in the way. So it just becomes it creates a non-functional creature. It doesn't make any sense because they can't fly yet, according to the evolutionists.
That to me is such a big deal. I mean, imagine this creature how does the halfway thing survive?
Right, exactly. Doesn't make
Ah,
sense. All right, so we got two, feathers and swivel wrist. Number 3, stabilized shoulder. So if you can shrug your shoulders, right, Eric? You can
yeah,
move your
yeah. I
shoulders
do it
around.
all the time when they ask me questions in there and I just have to go, I don't know.
Birds can't shrug their shoulders. I don't know if you knew
Huh.
that. They can't
No.
shrug their shoulders. So a person we can shrug our shoulders because the only thing attaching your shoulder, the only thing in your skeleton attaching your shoulder to the rest of your body is your little collarbone that goes right here. Uh,
Yep.
if you like evolved feathers and tried to fly, you would most likely dislocate your shoulder and break your collarbone because
Really?
you don't have the structural support for flapping. Turns out flapping is a big deal to a bird, right? To be able to fly,
Yes.
you need the support to be able to flap vigorously. Uh, and we see this, but we don't think about it, right? And so birds have a very special shoulder structure. It locks their shoulder into place. So the black bone there, scapula, the gray bone there is the humerus, which is the arm bone, and then the blue bone is a special bone called the coracoid. And you can see there's this sharp angle between the scapula and the coracoid, and it works. There's a fourth bone called the furcula, which is kind of the wishbone, and those 3 bones make kind of a tripod structure. And if you know anything about engineering, a tripod structure is pretty stable and
Very
secure.
strong. Yeah.
Yeah, very strong.
Triangles are the best. Yeah.
So it locks that shoulder into place so that it gives them the stability for that flapping. Dinosaurs don't have this. So if you look at Allosaurus again, they have a bone called a coracoid, but it's really just kind of an extension of the scapula, and it's kind of just in the same line of the scapula. It's not angled like the one in the bird. And this is consistent across. So we'd expect if these animals are birds to have that angled scapular coracoid. So if you look at Microraptor there, you've got that angle. The coracoid's a little bit different shape than the goose, but it's definitely not shaped like the Allosaurus. It's longer, it's more rectangular, and it's more similar to some of these other extinct birds we have, like Cathiornis. And so you can see the resemblance there. And this is very consistent across a bunch of these feathered maniraptors. And it's very consistent in the non-feathered dinosaurs, the Allosaurus, Sinosauropteryx, again, they just have that small rounded coracoid, whereas all these feathered maniraptors have this angled coracoid that's elongated. Now, I do see some variety. God likes variety in his creation. If you look at the ostrich on the far right there, you can see that angle's not as sharp. Well, what's different about an ostrich?
It doesn't fly.
It doesn't fly, right? And so it doesn't need as much stability. but it's still not a dinosaur coracoid. It's still longer and it's still got some angle there. And so Caudipteryx has a similar one. It's not as sharp of an angle, and Caudipteryx was most likely flightless. And so we can see some of those similarities. The other cool thing about the shoulder structure of a bird, it's got this unique muscle structure that's unique in creation. It's a pulley system. And so this is a dove, and you can see the that muscle attaches onto that breastbone there at the bottom, and then it loops up around and attaches onto the arm bone. And it loops through something called the triassial canal. And so when that muscle pulls down, it lifts the arm up because of a pulley system. So it's pretty
Huh.
remarkable. Dinosaurs don't have anything like that. They have a shoulder muscle called the deltoid, more like a human deltoid, and it just raises the arm. There's no pulley
Yeah.
system, anything like that. Well, the latest research indicates that many of these feathered maniraptors had something very similar, a very similar pulley structure. And so you can see Microraptor there in the middle. It's got that same muscle and it loops up through a canal right there. It's very cool.
That's insane. And it's literally like a pulley, like you're using mechanical advantage there as a pulley would. You're
Mhm.
literally taking that
Exactly.
large area and just, okay, wow.
And this creates a big problem for evolutionists too, because how did this muscle, this deltoid muscle, evolve into a pulley system?
That's a great question. Like that doesn't just happen. Like
Yeah. Yeah. They don't have a good explanation.
and what happened first? Did the feathers evolve first and the dinosaur go, you know what? It sure would be cool to flap these. Or did
Right.
that evolve first where he's walking around flapping his arms, going, this
Exactly.
is cool. I sure wish I could have evolved feathers. I mean, like,
Yeah.
how would
Right.
that happen?
Exactly. Yeah. Totally. So yeah, that stabilized shoulder joint. Now there's another shoulder characteristic here, the shoulder joint itself. So this is a modern bird, it's a European starling, and it's kind of a cross section of the front view of the starling. You can see the wing bone coming off to the side there. You can see the coracoid and the furcula coming down across the front of the body there.
I'm like,
And
you could see that. I could use some labels, but yes, I think I can. I think I'm imagining what you're saying here. Yes.
so that red semicircle is kind of that shoulder joint, right? That's where
Yes.
the the humerus, the arm bone, attaches to the rest of the body. And you can see that blue angle, that blue range of motion. And so this shoulder joint, it's located high on the body, it's facing sideways, and that gives the maximum range of motion for flapping.
Yeah.
Because you need range of motion if you're going to be able to flap your wings, right? There's just no way around that. Like you need that for productive flight. Could this guy fly? No, he could
Wow,
not.
those are really low. Assuming same kind of cross section, those are
Yep,
very low on the body, more like arms out in front versus
yep,
very high on the body like the bird.
exactly. Yeah, and a very small range of motion too. So
Yeah,
you
yeah.
can only move a
And
little
it's
bit.
green because it's green, not blue. And that's
No,
yeah.
that's the difference right there. So if we look at these feathered maniraptors, we'd expect to see a shoulder joint like the bird, and that's exactly what we find. It's
Interesting.
located high on the body. It's angled sideways. It's called the lateral facing glenoid, is the technical term, and it has that big range of motion. Now there
That's
is
cool.
some variation. Again, some of these uh, flightless uh, flightless birds, flightless feathered maniraptors, it's located a little bit lower, just like an ostrich would be, because they don't need that big range of motion for flight, but still very different from the dinosaur. This is a side view, and you can see the
Wow.
big range of motion in blue, and then the dinosaur, very small range of motion, just kind of angled backwards, like we normally expect in a dinosaur arm. But Microraptor, it's not a lot like the dinosaur. It's very different, much more like the bird.
No doubt. Wow. So four
So
main
here's our
differences already.
four main differences already. So we took these four main differences and we said, okay, well, we've got to make sure that we're looking across, like I said, it's over 100 different species, right? So we wanted to make sure that how consistent is this across these different species of feathered maniraptors and other dinosaurs. And so this is kind of the study of these first four characteristics, and we looked at them and analyzed them with a data set across all these different groups of animals. So the first AVLA, that's kind of those are the most bird-like animals. They're very much just birds. So the dromaeosaurs, which we talked about earlier, and then some other animals, animal families that typically have been considered dinosaurs: troodontids, oviraptorids, alvarezsaurids, and scansoriopterids. And so we looked at those. And then other animals that, again, have been considered dinosaurs, Coelurosauria, the tyrannosaurs, you probably recognize that name.
Yep, I got that one.
Ornithomimids, and therizinosaurs. So you can see kind of a pattern emerging here, right? Now, this is an evolutionary data set. And so there's already some assumptions built into the interpretation of that data and things like that. But even with an evolutionary data set, you can see there's a pattern here. The blue characteristics are avian, or bird characters. The green characteristics are what we'd expect to find in dinosaurs. And when we look into these exceptions, we find that they're either not surprising exceptions like the flightless bird thing, or it was just bad interpretation or bad data that made its way into these data sets.
Interesting. So now even the ones in blue there, I'm having a hard time reading them. It's a little too small. My eyes are going bad, getting old. But those are considered dinosaurs on the evolutionary in the evolutionary class, or in our modern scientific classification system. All of those would be classified as dinosaurs.
Everything below that first line would be considered.
Oh, okay.
Dinosaur. Yep. So bird.
Wow. So no wonder they're saying dinosaurs evolved into birds, instead of just saying we've got some things classified as dinosaurs that we should classify as birds. Is that kind of?
Yeah, exactly. Yep.
Interesting. Wow. And then you've got 3 more characteristics to go through.
I do. Yep.
Okay, I want you to do that, but I got to take a break right now and let my social media go. Hey, if you're joining me on Rumble, TikTok, Facebook, YouTube, Instagram, or Twitter, X, excuse me. Sorry, Elon. Thank you guys for hanging out with me. There's so much more to talk about. I can't wait. We're going to go through these other ones, and I really want to get down. And Joel, I want you to answer this before they leave. Did dinosaurs evolve into birds? I think I know your answer. But if you want to join the rest of this conversation, you need to come over to the Creation Today Plus platform, and it's a really cool way we do this. We don't charge any monthly fee. We say, hey, just donate. Help us, whatever you want per month. Help us reach the world with the gospel, and you get everything we do over here on the Creation Today Plus platform. So I'd encourage you to do that. It helps us reach the world with the gospel, and it's a great way for us to partner with you and reach more people. So we'd be honored if you'd come over to creationtoday.org, join the rest of this program, plus all the information and programs that we have here at creationtoday.org. So please join me over there. Joel, did dinosaurs fly?
No.
You're going to come to the conclusion that dinosaurs did not evolve into birds and dinosaurs didn't fly. We got to reclassify. Okay, I want you to get the rest of this. At least go to Answers in Genesis, look up his name, Joel Leineweber, and look up the articles on the Answers Research Journal if you're really interested in getting into this, and actually get this material so that you can do more research. Everything you're about to present has been presented in papers before. So it's out there, it's online, you can find it. I'm trying to make it really easy for you to access it here at Creation Today. Hey, before I let you go though, I want to show you something, guys. I love these shows. Next week, I've got a show coming out that we had a blast creating. I went down and did my own research. Joel, you'd be proud of me. Sliced my own dinosaur bones, looked under the microscope, and lo and behold, we have got some big time truth to tell. Kent, show them what we're going to be doing next week. This is incredible. You guys have put an entire lab together. And I'm identifying as a scientist. That's what I'm doing.
If you're in the lab, you got to wear a white coat.
All right. This is insane.
So do you know what we had here,
This is
Clint?
just sitting out here for you guys to look at. Look at these trilobites. This is the real deal. You're in one lab. You're able to go from the field to the microscope, and even, did I hear you say you're doing sequencing, DNA sequencing with stuff?
Yeah.
Gentlemen, I've discovered something incredible, and I'd like to find out what's inside of it. I have here hang on just a second, a Camarasaurus pelvis, and I'd love to know, what do we know about this Camarasaurus pelvis? I'm cutting the dinosaur bone open, baby. This is from a dinosaur.
Oh yes, I know. I was speechless for like the first 2 weeks when I saw that. It is stunning.
So we got something amazing. Oh, I can't wait for that to air next week, guys. We're going to expose the truth at this creation lab about dinosaurs, and they are finding, as Jill knows, some incredible stuff inside of dinosaur bones that should not be there. Can't wait to do that next week. So thank you guys so much for joining me. I look forward to seeing you next Wednesday. Between now and then, after you go to answersingenesis.org, and after you subscribe to their newsletter, and after you look up Joel's article, and after you give Answers in Genesis a donation, would you go share the gospel with somebody this week? Would you make a difference in eternity with the time God has given you in the next 7 days? I love you, friend. Can't wait to see you next Wednesday. Until then, let's go share the gospel with somebody who needs to hear it.